Hello, I'm Dan Olds on behalf of Hyperion Research at Inside HPC, and we have a special treat today. We're going to be interviewing Ryan Quick. So, Ryan, can you introduce yourself a little bit?
So my name's Ryan Quick. I am with a boutique consulting firm called Providentia Worldwide for the last almost 3 years now. Before that, I was with eBay PayPal since early 2000. And we did what we called atoms and galaxies for them. So we ran very large supercomputers for their
Ah,
fraud analytics and risk systems, and then we also did small mini board computers and custom hardware and things like that in the very small systems, and
okay.
not the stuff in the middle. So the very small atoms and the very large
Large.
galaxies.
You left the
Hence,
middle
hence,
alone.
so yeah, well, we did that when we first got there in early 2000s, but we left that stuff behind in about 2008 and went to the other stuff. So for about a decade, we ran their supers.
So, how'd you get involved in HPC in the first place?
Um, I had a problem where we had fractured their database. What they call it now sharding. We called it splitting at the time,
Uh huh.
and we were trying to. That worked really well, but you had to have the application had to understand what you had done there. So you could split it up to be able to make the database faster, but then you had to have your application understand what you had done in order to be able to put that back together. So call that the Humpty Dumpty problem. So you could throw
Yes.
Humpty Dumpty off the wall, but your application had to know where you broke him up. That was great, but then your analytics people were like, well, we don't know how to put him back together again. So hence
Yeah.
the Humpty Dumpty problem. So he had been tasked with constructing something like a data warehouse to put it back together again. And so we had this problem where we could either keep the database up to date and by putting it back together again, we could either keep the database up to date
Okay.
or we could query from it, but we couldn't do both at the same time. So
Ah,
we could build a single database that was fast enough to keep all the updates coming in.
okay.
But we had to stop it
If you wanted to run a query.
if we wanted to ask it a question, right? And so that wasn't going to go. It wasn't going to work. So I went shopping on the internet, and I was like, hey, in my before time, I lived in Northern Virginia, and we used to run in my basement. I had a Challenge XL and some other gear I had picked up from NASA.
Oh, wow. Okay.
In the state sales that they used to run out in at the Oceana Naval Air Station and places like that. We would pick up stuff that we would use as heaters and that happened to have reality engine and stuff like that in them. And I was like, I wonder if one of these, I haven't used a real SGI in a long time. I wonder if they've got something that might be able to do it. So yeah, I went shopping right before Christmas.
Uh-huh.
This was 2004. Yeah, 2004. I cold called right after Thanksgiving. I cold called SGI and said, "Hey, I'm looking at this Altix. The 450 was what I went, and I said, "Hey, you don't really have anything on there that says that you can do this, but I'd like to buy one of these things, a baby one, and I'm going to try and run MySQL on it and see if I can build a database that can simultaneously keep this update rate running and be able to run queries on." And that's what we did. I went shopping, bought an SGI, and we actually were able to do that. So that's what we did.
They must have been pretty interested in that use case.
They were. Well, first I had to convince Chippewa Falls that running a database on top of an Altix was something that I was allowed to do.
Okay.
but we actually moved off the Altix slightly before it became UV. It became UV right after that. But we moved off the Altix. We kept that one around because I did buy it. And then we moved to the ICE platform after that, and
Okay.
then after that we kept a hybrid after that because we actually had use cases that were good for the large shared memory footprint and for the scale out platform. So we always ran a hybrid cluster with mix of both. So we had both UV and we had scale out ICE from then on out.
So, what are some of the biggest changes you've seen in HPC over your career?
Um, what HPC means to different people. It used to be taboo for wherever you were to talk about anything different. So if you were like a weather guy, HPC was like weather, you know. Uh, and if you were like a physics guy, it was physics. Now it's gotten to be a little bit better. You could talk about not just what you do, but you could talk about what other people do. In fact, I was asked by the SC19 committee last year in the summer to write an article for them.
Mhm.
And so I wrote a blog piece back last year specifically about that. Like, and I called it open HPC, where that was basically the theme of it was like, hey, we finally gotten to where we can actually talk about different types of HPC. Wouldn't it be nice now if we would actually sit in each other's BOF sessions and maybe start sharing what it means to us, and maybe we can learn from each other,
A brave, brave man.
yeah, not just
brave
not
new
just
world.
yeah. So instead of just not being, elbowed in the face as we walk along for coming from different, we've stopped that. Maybe now we can learn from each other. So yeah, that's probably the biggest thing is that you don't get, not only do you not get in trouble for having a different pedigree, now we are getting to where we might actually be able to learn from each other. That's what I'm hoping.
That's a heady world that you're imagining. Wow.
Yeah, trying. Yeah.
Very good. So again, looking forward, what do you see that either excites you or concerns you, and or either?
Let's see. Concerns me is probably the easiest one to start with,
Mm-hmm.
and that is that we'll close the doors on innovation in the name of speed. And that actually
Ah,
comes because of the COVID stuff. So I think COVID is probably, it's a horrible, unfortunate thing to happen to the world, obviously, but it's actually a big boon to large scale computation
yeah.
in the world, because it's going to speed just like it's speeding up how we're going about doing drug trials and things like that. It's also going to speed up how we learn about large scale computing, because
Yes.
we're going to finally try some stuff we've never tried before. But what I'm also afraid of at the same time is that we're going to get one new thing that works, and that's all we're going to do. We're going to figure out one new way of something, and then everybody's going to be like, well, great, we learned something new, and then they're going to slam the door behind them. So
So
rather than keep the
yeah.
screen door open and allow a few more things in and try several things, we're just going to get one new thing that works and go with that. That's what I'm afraid of. So that's probably the biggest thing.
So whatever methodology, for instance, for example, solves the COVID-19 crisis, that'll be the
one thing that
holy thing,
yeah,
holy grail, and we won't pursue anything else.
yeah, it'll be like CUDA 2. It's like, well,
Ooh,
could have been a CUDA 3 and CUDA 4, or a something other than CUDA.
Barracuda.
Right. Yeah. Something. So that's probably the thing I'm worried about with it. It's software, right? There's lots of ways of solving software.
Sure. What excites
Um,
you? Anything?
uh, yeah. So the thing that excites me most is that finally I've gone 6 months now, and I haven't been asked to explain why containerization um, is a different way of doing virtual machines, which is great. Because, and I'm not even going to go into here, I'm going to let that stand. Now you're going to have to explain it in the comments. I'm just going to let that stand, but that's good because I've made it 6 months without having to justify that statement. But that means that we've finally gotten somewhere with containerization, and that means it's come into its own in the HPC world, which should open the door for all of the things that containerization can actually do for us. And not simply look at it as a way of lifting and shifting workloads, because that has been in our way for almost a decade now. And I am finally going to get to see containers come into their own. So a little bit of history there for me.
Mhm.
In 2006, I was working for PayPal at the time. We went before the Visa committee to get Solaris containers approved for the PCI committee to allow Solaris containers to be approved for doing payment card industry isolation
Okay.
for Oracle, specifically running Oracle database running inside of Sun Solaris. This is prior to the
Okay.
acquisition, right? And so I've been sitting here going, look, if Oracle was allowed to process, Oracle databases were allowed to process payment card in isolation inside containers in 2006, why are we still debating this technology in 2020 as being is being isolation tech?
Good point.
So and so for me, it's like I can't believe I'm still having this discussion, and so it's finally getting there with Linux, and that's making me really happy. So that's good.
Very nice. The fulfillment of a dream.
Yeah.
Where do you see HPC headed in the future? Are there any other trends that you are looking at, keeping your eye on?
Yeah, I think we'll finally start to see the bleed of my company now, we work in this gray area where hyperscale, AI, and HPC all sort of meet and mix, because there is this sort of Prometheus bringing fire across the way in between those. And that's kind of what we do is we sort of beg and borrow technologies between the different entities, and bring them to the other side, mostly because the vendors aren't well aligned at being able to bring technologies from one business unit to the other side. So I won't name names here, but like pretty much all of the different vendors all have technologies that are capable of delivering this solutions across the stack, but usually those one particular technology is aligned with a particular core business unit. So
Sure.
high-end clustering might be associated with the HPC business unit, whereas scale out object file system or object technology might be associated with a different type of storage in the enterprise or in the hyperscale unit. Well, if you tried to take clustering and wanted object stores together, they may never
No.
talk. Right. And so trying to buy that might be nearly impossible, right? Depending on who your sales reps are. And unless
Yeah.
you're a tier one enterprise where you can force the right people to be in the room for you, that you may never be able to buy that from the company. Even if you can go to the website and be like, look, you can buy, like, right there's the SKU. I want to buy
It all
that.
works. It
Right.
all works together.
Yeah. So I think we'll finally in the HPC world start to see some of those technologies really start to mix and match, and that'll be a good thing. And I think it'll be driven by edge and IoT, especially because they're starting to take some of the really high end HPC class hardware and cram it into smaller stuff,
Yeah.
which is great because now you're gonna see small stuff start to do some really really neat things, right? It's one thing to have a cool drone flying around your house, but when that drone is processing 16 or 24 4K video streams at one time and
Oh,
wants to be able to do facial recognition as it flies around your neighborhood, now that's some cool HPC that's happening while that thing's flying around, and something's got to analyze that stuff. And now that's getting into some serious HPC that's flying around your
no,
neighborhood.
no
Yeah,
kidding.
that's cool stuff.
That's some serious back end.
Yeah,
Well, fantastic. Thank you so much for the time, Ryan. We really appreciate it. And I know that all of the listeners and watchers out there are going to vastly enjoy this. Thanks again.
yeah, appreciate it. Thanks, Dan.